Hi everyone, welcome to my channel Tutorials and Tips. Today I will show you how to create MLAG, also known as multi-chassis link aggregation. I am using Arista VEOS, it's a virtual software, just to show you how to create the MLAG using EveNG as my lab. As you know, Arista is quite popular as a data center switches, and in your data center you would want high available collapse core or core design. Using these two Arista cores, you could create that very easily. Creating MLAG is very simple. I would say similar to VPC and or VSS, but this is much easier to create. You can see I have Arista Core 1 and Arista Core 2 have two connected links. I will use that to create my MLAG. They will be called MLAG peer link. I do have an access layer switch right here, and I will show you using MLAG how you can achieve the high availability. During a maintenance or maybe a hardware failure, one of your core might go down. In my case, I will bring down core 1, and you will see how this PC can still send traffic using the active MLAG peer, which is in this case Arista Core 2. So quite a lot of things to cover. I will start with configuring Core 1, then I will configure Core 2. Arista switch down here has already been configured with basic spanning tree, and I use VLAN 2 for example, and I have assigned a static address on this Windows PC from VLAN 2. Let's just see. I'll show you how to create MLAG and how to do a basic troubleshooting. Now, MLAG or multi-chassis link aggregation. In case you did not get the name, this particular switch, let me clear it. This particular switch connects to two different physical boxes, two chassis, multi-chassis, and this link aggregates the connection between those two uplink devices, and that's why the name MLAG, multi-chassis link aggregation. So let's get started. I have core 1 here. Give it a name. I would like to also mention this point that in order for MLAG to function properly, or actually to provide the correct high availability for your access layer switches, you would want to match configuration corresponds to your spanning tree, your VLAN database or VLANs between your cores. You need to make sure those two configurations matches in core 1 or core 2. point, I have MLAG configuration. The basic configuration for that is completed on core 1. Let's go ahead and configure core 2 with the basic spanning tree and VLAN and MLAG configuration. So that's done. Let's take a look at MLAG status. As you can see, MLAG1 domain ID, and it's an active connected. If you wanted to see what state this core 2 is, you want to do details, and up here you will see that the state of this switch is secondary. Over here, let's do show MLAG details, and this is my primary switch. Now for this video I would use VLAN 2 to test the high availability part, so I have to create an SVI for VLAN 2, and I will be using VRRP as my FHRP, first hop redundant protocol, to simulate the gateway feature or for VLAN 2, how it is resilient, and the VRRP IP.1 would be hosted on core 1, but during maintenance or any kind of failure, if core 1 is not operational or goes down, that address would move back to core 2 and gateway function for VLAN 2 will continue to work. So I would use physical address .2 here, physical address .3 here, and .1 would be my high available address. And I have to enable IP routing for that to work. So let's get going. Now just a quick demonstration, VLAN 2 SVI. I'll just go ahead and shut it down on core 1. And you will see that the master role would be migrated to core 2. Voila. Bring this one back, it should come back. Takes just a couple of seconds for it to come back. Alright, this part is done. Let's go ahead and configure the port channel that will connect these two core with the access layer switch. We will be using port channel 10, and on core 1 I have ETH2, and on core 2 I have ETH3, part of that port channel 10. Please make a note, this is an MLAG port channel. Right here within the interface port channel 10 configuration, I have mentioned that this is an MLAG 10, and this configuration is same on core 1. This is the reason that Arista switch here knows that I am connected to a port channel that's called port channel 10 to an MLAG port channel to two different devices. Otherwise, it will not form the port channel because it will consider two different boxes and it will error disable the port. Because of that MLAG 10, this multi-chassis link aggregation, this aggregation actually happens. Let's take a look at it. Port channel 10, I have two ports connected. Here is as well, you could see the Ethernet 2 local interface and partner interface 3 is also in use and bundled. So let's go ahead and take a look at the access layer switch and the port channel configuration for that one. For this video, I went ahead and configured that one, but I will walk you through the running configuration. Here I have running spanning tree, rapid spanning tree. I have VLAN 2 created. I also created port channel. This is just a regular port channel for this switch perspective. Nothing special. It's a trunk. It's carrying all the VLAN. According to the diagram, I have ETH1 and ETH2 and ETH3. ETH2 and ETH3 connected to upstream devices. So ETH2 is part of 10 and ETH3 is part of 10. They're all doing LACP. Now ETH1 is an access port connected to my PC, the Windows PC, over here. Let's see, and that's about it. I have interface VLAN and SVI configured with an IP address, a basic IP routing pointing to the .1 HSRP address. That's it, nothing else. So let's check the port channel configuration on the access layer switch. I have both the ports connected to core 1 and core 2 with LACP. I should be able to ping the .1 address. .2 physical address of core 1 and .3 physical address of core 2. All is reachable. Now I wanted to show you the MAC address that this switch is connected on ETH1. You can see the MAC address. I just wanted to show you when I pull up the VNC station for Windows 7, I'll show you that's the PC. Here you have it, guys, 501400022000. It's configured with .15 gateway.2.1. So here I will start my continuous ping. And you can see it's pinging. So we are ready. We will go ahead and save our core 1 and core 2 configuration, and we will reload core 1. And you can see that it might lose one packet or might not. This is a lab virtualized, so if it misses one packet, don't be too surprised. But I have tested this several times on a live gear and literally no packet loss. With Arista, they say 1 or 2 packet loss. It's still within the parameter, but I have seen it with no packet loss in real live gear. So let's go ahead to core 1 and core 2. I'll move this one on the side so you can see it. Core 1 here, let's go ahead and save, and core 2 here, let's go ahead and save. Just wanted to show you that this is still hosting, core 1 is still hosting the VRRP address of VLAN 2 master, and it is still the MLAG primary. Show MLAG detail. This is still the primary role, so it's saved. Let's go ahead and reload. There you have it, just one packet loss. Show MLAG will show you the timer that is in active reload. Give it a few minutes and it will come to an active reload state. And there it is. Just wanted to give out a few points on MLAG, show MLAG command. Here you can validate your MLAG domain ID. Any pair of Arista switches in an MLAG should match this for them to join in an MLAG domain. VLAN 4094 dictates here that that's my inter VLAN inter MLAG peer interface. Peer address dictates that with this address they send out heartbeat packets, and it detects that my peer is up or not. I think it's every 8 seconds. Peer config is consistent. Now this is very important, as I was mentioning, that you have to make sure that your configuration matches, your base configuration matches between both the cores. If they're not, here you will see an inconsistent remark. You can also do a show mlag config sanity command that will also show you what are the inconsistent command between those two cores or configuration. Several times when I'm troubleshooting MLAG situation or configuration issue, show MLAG config sanity has been the lifesaver. It dictates that what is matching on the active peer and what's missing on the peer device, and then you can quickly make those adjustments. And with show MLAG again, you can verify that your peer configurations are consistent or not. Let's see. 2 minutes 14 seconds left. I will speed up this video. It's down to seconds now, 15 more seconds, and I wanted to show you that it becomes an active state from active reload. By the way, you can change this idle timeout within the MLAG configuration command. They recommend it for 300 seconds, so it will throw you a warning. Okay, it's connected and it's active. I wanted to show you that MLAG, this peer, it is after reload becomes the secondary. It will wait for the current active to reload before it will assume the primary role again. This switch still should be the master for the VLAN 2. So there is that. The command I wanted to show you was show mlag config sanity. Here with this command right now, there is no configuration mismatch, so everything is good. For example, remember we created VLAN 2 to 10 on both those switches. If I were to take the last three, for example, no VLAN 7 to 10, that's fine. Now my VLAN database only has 2 through 6. Let's take a look at show mlag config sanity, and it will tell you that inconsistent attributes 7, 8, 9, 10, local value nothing, but on the peer value, if I expand this, you will see on the peer value it will show you that they're active on the peer value. And again, if you want to reload at this time, it will throw you that same inconsistent message with what is inconsistent. Very great command to troubleshoot MLAG related configuration. But just wanted to show you how easy it is to create MLAG using Arista devices, and hope you like this video. I'll go ahead and fix this inconsistent configurations. Back to 0, we will save it. And there you have it, MLAG using Arista devices. Pretty easy compared to VPC. I would soon will create videos with Cisco Nexus VPC, how to create VPC using two Nexus switches. Please stay tuned for that. If you like this video, please don't forget to give it a like and subscribe my channel for any future videos. Thank you very much.